It's really a pleasure to have in a conversation one of the actual participants in the course, and he's quite a unique participant. It wasn't what I was expecting. Here I am, a professor at the University of California, Santa Cruz, expecting to teach sophomore and junior computer scientists some C++, especially as it goes to doing some game-playing software development, which is a specialty here. And I have, for our conversation, Professor Steve Gribble of the University of Washington. Hi, Steve.
Hi, Ira. It's a pleasure to be here. Thanks for having me.
So I guess one big question is, why are you a student in the class?
That's a great question. There's one major reason, which is at the University of Washington, I actually teach a similar class to you called Systems Programming. And one of the things that I'm considering is whether or not to offer that course through Coursera next year. And to figure out whether or not that's a good idea or a bad idea, there's a number of things that I wanted to understand. I wanted to understand what the experience is like for a student. I wanted to understand what range and diversity of students I could expect taking the course. One of the things that's very similar to your course is, since it's a programming course, I want to have my students writing a significant amount of code and being able to understand whether the code that they're writing is good or bad through various different metrics. And as a result, I wanted to experience what it's like to submit projects through the Coursera platform and have other students read and grade my code. So basically, this is a chance for me to field test my own course through your course and understand what the opportunities and pitfalls, what the pieces of infrastructure that I think I need to build are, and so on.
Okay, well, you've landed in the right spot. I hope, for one thing, I hope you have a thick skin. So one of the really interesting things is when you have 52,000 unique emails who have signed up for your class, they're all over the map. It is not the kind of homogeneous experience where in my local course there would be 100 sophomore juniors all prepared to go on in computer science and all having prerequisites. Here there are people who are disparate, non-homogeneous, and I think this presents one of the really interesting opportunities and challenges of the course, and where, you know, I've probably gotten the most criticism because I'm not satisfying a particular audience. But I think what's challenging in this new environment is it's just different. So how do you proceed? How do you reach out to the audience? Now, one of the really great pluses is unexpectedly there are people like you, and there are people who are incredibly professional. From what I can see, they are in industry who are hanging out in the course, posting to the forum, and these posts are just remarkable. And indeed, that's how I spotted you. I didn't know who you were, but you were among the highest posting forum people. And I would read those posts and I said, boy, I wish I could write my code as well as this guy is writing his code. And I wish I could reply to some of the students' questions with the kind of insight you had in some of those questions. So I think that's really remarkable, but one of the real challenges is just the heterogeneity, just the differences and variations in audience over and above, even when you specify, and I'm sure you'll do the same thing I did, you'll say, this is the background you need for an upper division operating systems course, and you'll say A, B, and C, and then you'll find people who won't have had that background, but still expect for you to deliver a course that meets their needs. I don't know if have you given that some consideration?
I have, and it's actually quite a challenge. There's some good parts to this diversity. As you noted in the forums, there's an extraordinary amount of participation, and the good thing about the diversity there is that there are plenty of people taking the course who are professionals, and as a result have a significant amount of expertise. It can sort of amplify the instructor's own teaching capacity. So as a result, there's a very quick time to reply for anybody's questions on the forums. There's a diversity of opinions as well, and it's pretty easy for somebody of any skill to pose a question and get a very helpful answer quite quickly. And that's a remarkable thing, given that there are thousands or tens of thousands of students taking the course. So in some sense, that diversity is an advantage for building a community and the interaction. It's a challenge for the instructor, though, because at what level do you pitch the material? If you target the people who have the least experience, the course will be too slow-paced for those who have more experience. If you target at the top end, you'll lose most of your population. And if you target in the middle, half the class will be bored and half the class will be too challenged. So it's perhaps a little bit easier in a university environment where a course like this happens after a prescribed series of prerequisite courses. So you know that all of the students have at least seen similar sets of material in the past. Something that I know people have done successfully in courses like this is structure the material so that if you're relatively new to the topic, you'll be able to do some of the projects and maybe not complete the entire sequence. And that's okay with something like Coursera, where it's good to complete the course. It would be great to get the certificate. But there's a little bit less at stake than when you're paying a very high tuition and actually are enrolled in the university, and to some degree your grade is at stake and your transcript is at stake. Another place where this is a very big mystery to me, and this is one that I've been thinking a lot about, is in the topic of peer grading. So particularly for programming, this is actually more important of a skill than you might realize if you're new to programming in general. If you're in industry, it's definitely the case that you'll write a lot of new code, but you'll also spend a lot of your time reviewing other people's code and critiquing it, and generally trying to improve a code base. So as a result, something that peer grading gives you, which is very much a real skill that you need, is the chance to read somebody else's code that you didn't write and try to figure out whether it's good or bad, why, and how to go about improving it. And as I think a lot of the students in the class are finding out, it takes a fair amount of time to complete the project and submit it, but it actually takes a lot more work to read, understand, and critique somebody else's work than it might even to complete the work of your own. So that's sort of a hidden, unexpected cost. But if you can get good at it, then you'll be an incredibly good programmer. Something that I found as a teacher is I learn the material much more deeply when I try to teach it than when I'm a student. And peer reviewing is a chance to do that. Now here's the downside of peer reviewing. There's a lot of people taking the course. Some of them are more committed than others. So the challenge is, if I'm relying on somebody else to critique and hand me a grade for my course, for my work, there's a relatively good chance that somebody who's not invested in the course or is not yet capable of judging the material accurately will be responsible for assigning me a grade. And that can be pretty frustrating. So this is something that I think MOOCs in general are going to have to confront, which is, how do you go about making the peer grading process productive and also fair? And it might be something along the lines of coming up with community ratings for peer graders, or it might be some other technique that helps along the way. But until this part of the MOOC process really gets ironed out, there's going to be a lot of hand-wringing and consternation about it, I think. This is one of the big unknowns.
Yeah, well, this is This came up for me last year when I was teaching 100 students in my normal class, a precursor to this Coursera course. And in those 100 students, we used a newly developed system by Professor Luca Del Faro, who's on our faculty, who is highly regarded when it comes to how you develop reputation on the web. That seems like you study things like the Wikipedia, where people place things and get a reputation, or you can think more simply, I know you're a Washington guy. Well, there's Amazon. What if you go to Amazon and you ask about a TV and you get 54 reviews? I mean, how should you trust those reviews? Well, he has, in fact, he has a PhD now working on what's called CrowdGrader, and it's actually open source, where he's offering people throughout the world an attempt to use it so he can do his research and actually address these questions. But locally, what I thought just the way you thought. I said, you know what? The professionals I know in Silicon Valley, they're spending just as much time reviewing other code as they are writing their own code. You have to be able to understand other people's code. There's peer review coding sessions all the time. That is critical. I don't know why we at the university, I understand it now. Our old methodology was, gee, you give it to the TA, he grades the work, he's supposedly nearly a professional, and then he returns to the student, and the student doesn't grouse about it.
Right.
So that was quite acceptable. Now you go and you peer grade it, and you get exactly the flack. In fact, I got a lot of that. I mean, it was a course that was well loved, except the students hated grading each other, and then the typical complaint was, this idiot who doesn't know anything, who is his peer, graded me. What can I do about that? He just didn't understand anything I do. And this is, as you quite well point out, is exacerbated and amplified in a MOOC, where there are people who are taking the class for whatever reason, who are consummate professionals, and there are people who don't have the background and are just struggling to try and understand it. And they all deserve a shot if they have an educational opportunity. For me, philosophically, it wasn't about the grade. It was about the participation. It was about the opportunity that the legitimate student could have as a learning opportunity. If I had worried about the accuracy of the grade and what that would mean, I would be somewhere else than allowing for peer grading, because I think I agree with you completely. There's the downside. I mean, especially if you ask Luca, who I talked to earlier today about some of these issues, he said you need at least 5 peer-graded assessments, and they probably have to come from a relatively uniform base to be statistically accurate. That's just not happening, because partly it's a scale thing here on Coursera. I was advised that I should not ask for more than 3 peer grades. Also, the lots of people who are hanging out on the course don't have enough time to do it. Indeed, there's some reason to think that they shouldn't even, if they don't have the time and energy, they shouldn't even try to do all the compilation, because that can be complicated with a C++ compilation. They should just look at readability and try and make a judgment there. So I know that some of them are sincerely putting in major effort to understand, even possibly examine and debug and comment in detail on these projects, and that's great. But I think from the perspective of them being participants here, they should feel that they're getting a benefit rather than somehow it's being imposed on them.
Right.
The upside, as far as I can see, and I know you're entertaining doing such a course, is it scales. It's flexible and it scales. So if you're going to have 15,000 people doing submissions, uh, there isn't a scheme unless you're going to, and indeed, as I understand it, some of the classes that use Python or Java, where you have a very standardized environment, a JVM or a similar thing for the Python virtual machine, they can ask for a deliverable that then can be fairly routinely tested. So you can get some automatic tests. It's not as easy in the C++ community. Now, maybe we'll be growing there in 5 years or whatever, but it's not there right now. And the flexibility to me was one of the attractions. So that's something I think you want to think about. I don't know how you feel about, again, one of the difficulties, and I'd like to hear your thoughts on this, is, well, I've been in the C++ community since 1985, since when I actually went and talked to Bjorn at Bell Labs, when I was going there actually to meet some other people, and they said, oh, well, you already wrote a book on C. You should meet this guy who's trying to do the next version of C. And so they sent me down to his office. And this guy explained his stuff, and he said, well, do you know Simula? I said, really? I know it's some weird, invented in Norway. And he said, well, that's how I got trained, and I'd really like to put classes into C, and that'll make a big difference. So that's what I've been doing. And then I just got into the idea, and I thought it was quite wonderful. But, as you might know, by the time 1990 hit, if I have all of Bjorn's books. I have edition 1, edition 2, edition 3, edition 4. And for a while, they doubled in size. So you went to one version to the next, and if you have that, well, you're an OS guy, so you probably have Kerning and Ritchie
Oh, yeah.
edition 1, and that's how Bjorn started out writing his book. Well, now it's 1,100 pages and awfully dense. This is edition 4. I'm just wondering from your perspective, and maybe with your own students, what are your variables in sort of saying, okay, do this in C++. You say, hey, it's going to be only on this compiler, or you have to stick with this subset, or how do you address that?
That's a really good question. You're exactly right that C++ has grown in complexity over time. On one hand, that's a good thing because it's adopted more powerful features, object orientation, templating, more recently, things like range loops. I know you're talking about some of them in the class. But the truth of it is, sort of the way that I think about C++ is it's actually a large enough language that you can impose on it a family of different styles of programming. So if you do a simpler language like C, to first order, most of the C code that you'll ever write or read kind of looks the same. It's got a small number of patterns and tricks and idiomatic ways of coding. Whereas with C++, there's a much broader way of doing it, a much broader range of ways that you can program using it. And that's actually very dangerous. If you're not careful, you can fall into a very large number of pitfalls with C++, like not being disciplined about who owns memory and whether or not you're going to clean up memory inside of a destructor or somewhere else inside of the class. So what's really required with C++ is a lot more discipline than with another language like C to prevent you from picking up bad habits and abusing the power that the language gives you. So the way that I teach it is to essentially find a rational, simpler subset of C++ and have my students stick to that. So for instance, start off with, I don't have them use exceptions because there's actually a fair amount of complexity in using exceptions safely. So I sort of have them use the old C style of propagating error values through return values and to get into the habit of checking for errors every time that you're using a function that might return one, rather than using exceptions. So the trick then is figuring out what the good, safe subset of C++ is that simultaneously gives you enough of the advantages of C++, so you're not just stuck in the old C land. I've patterned a lot of what I teach off of the Google C++ style guide. I know that Google writes an awful lot of C++ code, and they've got a lot of experience with what works well and what leads to trouble. Early on in the course, I posted into the forum a link to that style guide. And something that I'd recommend that people do is read through that style guide, not necessarily because it's the one that they should use, but because it raises a bunch of issues you might not otherwise be aware of with a language as complex as C++, discusses both sides of the coin when it comes to considering whether or not you should use a particular feature and how you should use it. And then students can come up with their own decision about what's safe to use and what's not safe to use. Something else that I encourage my students to do is to be very uniform in their style, and that's more than just being picky and pedantic. It turns out that if you code consistently, and if your peers around you code consistently to a particular style, then there's a much lower cognitive burden when you're reading and reviewing somebody else's code. You no longer have to spend any brain power or brain cycles trying to compensate for differences in style, but rather you sort of see past the stylistic issues and can immediately focus on the algorithmic and correctness issues. So that's another way that I sort of teach the students. Something else that I'm a pretty firm believer in is unit testing, regression testing, and spending as much time writing test code as you're writing actual code. And that imposes a bunch of discipline on you. You really sort of are forced to think about what the corner cases are, what it means for your code to be good or bad or correct, and as a side effect of writing the test code, you actually partly document your own code. People can read the tests to understand how to use it. And now you also have this sort of safety net that as you change your code, the unit tests will teach you whether or not you've broken something. So there's sort of a whole range of techniques and pieces of discipline that you can use to combat the complexity of C++ and sort of tamp it down to a rational subset that has a lot of the power of object-orientedness and so on, without leaving you exposed to a lot of the pitfalls and traps and subtleties that a language can otherwise impose.
Oh, that's wonderful. I also have, in an earlier era, I was a great devotee of the Taligent style guide, which was sort of a 90s version of what Google now does. So there are several of these guys that have been posted. I think they can still be accessed. There was a very famous guide from, I think, a Swedish telecom company also called Elemental that also had many of these provisions exactly along lines that you're talking about. Now, one of the things, a fun thing, I wish I had more time to actually engage in all of the interesting issues that get raised. The students probably don't understand that there's a lot of moving pieces. Like one thing that takes a lot of time is the way the subtitling works. You'll find this out. You're going to have to read all of the subtitling, which at first I didn't even know existed. And now I realized that that's very important for the non-native speakers, and even something like C++ gets rendered in the subtitling as C plus spelled fully out, plus spelled fully out. That's a remarkable time sink to just thought of this. But some of the fun things that have shown up, for example, was, and I don't know if you saw the thread about using namespace std, whether that's good industry practice or not. And so I tried to track it down because in my writing books now for 15 years, it just was very simple and obvious to say using namespace std. And if memory serves, Bjorn was using it, and indeed he's the guy who put it in the language. So it just made some of the qualified names a lot easier to use. And certainly from the point of view of what I'm teaching, and you're clearly aiming at a much more industrial software engineering perspective, and I'm the course I'm doing is sort of more algorithmic and more sort of available to, I think, a more a student in a different part of the curriculum, especially in our curriculum here. Nevertheless, I then sort of plunged into it and sort of found all these interesting quotes as to whether using namespace would even be in the language or not. And it was just a lot of fun. And then my favorite among them, and I don't know if you had any thoughts on this, was one of the serious books that I was reading about truly writing efficient code, efficient and industrial code, said the whole methodology is too 1970s, too file-based, too going back to C. A lot of modern, even Ada style, even in the 80s, this would not be a worry for the programmer. They wouldn't have to figure out where to stick their .h files, stick their .cpp files, worry about why inline has to go there and not there. Maybe even inline would be thrown out of the language pretty much like register got thrown out of the language, in the sense that that was better for the compiler to figure out that optimization than for a human. Well, please see if that should be a register. Please see if that should be inline. So it was great fun. I don't know if you followed that thread, but that's some of the opportunity that shows up.
It's really interesting, actually.
You haven't?
No, I did see that thread. You brought up a bunch of topics there, and they're all very fascinating. One of the things that you learn as you progress as an engineer is that once you start dealing with large code bases and complex software artifacts, a lot of the things that you could get away with when you were programming relatively small, a few hundred or few thousand line programs, will actually get you into serious trouble as you deal with very large artifacts with hundreds of engineers and hundreds of thousands or millions of lines of code. So the namespace issue isn't so much of a problem if you're dealing with a small amount of code. But if you're dealing with a program that compiles and links dependencies that have been written by hundreds or thousands of other engineers, then all of a sudden there's a lot more risk that you'll accidentally import a conflicting symbol into your namespace if you import an entire namespace. So that's where a lot of these practices that aren't immediately apparent as you're learning the language, things like a style guide, a more robust or sophisticated style guide can teach you about and save you from. Now, you've also mentioned that people think that C++ has sort of a lot of old C anachronisms, and I think that's to some degree true. On one hand, though, the kind of control that C and C++ give you is very important if you're writing very low-level code, like device drivers or operating systems, where you need to very precisely predict what the compiler is doing, what the likely instructions that are going to be emitted by the compiler are, how data is laid out in memory, and so on. So there's always going to be a need for code that doesn't shield you, or a language that doesn't shield you from a lot of the low-level details if you're into writing that kind of code. Now, on the other hand, a lot of the hassles of C and C++ might be unnecessary, like managing header files and tracking down dependencies and things like that. Recently, sort of a new language has cropped up that's, I think, increasingly the darling of the Silicon Valley crowd, which is a language out of Google called Go. And this was actually authored by some of the people who were involved in the development of C and the early Unix systems and Plan 9 systems at Bell Labs, folks like Rob Pike and so on. So they attempted to craft a language that like C++ and C, is efficient for writing large systems, but unlike C++ and C, loses a lot of the hassles of the language. So for students who are interested in this sort of a thing, after they've gotten through the course and gotten a taste of C++, they might go take a quick peek at Go and see how a modern take on a systems programming language is. There's a lot of things about Go that I like, a few things about Go that I don't like, that'll probably be changed over time. But it's interesting to see how whether or not Go captures a lot of the benefits of C++ relative to C, while shielding you from a lot of the pitfalls of that very large complexity that C++ can lead you to.
Now, now I'm going to try to wrap up, but I'd really like to hear, is there a favorite feature for you in the latest C++11 that, I mean, I was flabbergasted when they threw in lambda expressions.
I've used
because
lambda
I was taught lambda by McCarthy when I was a Stanford graduate student. So to see
like
them turn up in C-based.
Yeah, no,
do you have a favorite feature?
I have a couple. I really love auto, just because it's a super hassle to figure out what the right type is when you're dealing with templated classes with iterators of all sorts of types. So that makes programming, I think, more efficient to be able to lean on that. I like range-based for loops in general because they plus lambdas start to make the code feel a little bit more functional. I'm not sort of a huge functional programmer myself, but I appreciate a lot of the elegance and style that style of coding brings. So I like seeing a little taste of that in there as well. I also was pleased to see threading support being added to the language itself. That was kind of interesting to see. It's a whole can of worms, though, and one that I suspect you're not going to be bringing up in this class.
The writing, give me that again. Which support?
Oh, support for threads inside of the language, threading.
Oh, support, yes. I'm actually possibly going to try to, it won't be in the class, so it's not in any of the modules, but I'm hoping to get a conversation potentially with somebody like Hans Bohm, who, as I understand, was deeply responsible for that model, and see, you know, in a conversation where somebody could suggest where the students could go, because, you know, as somebody in our curriculum, we teach a lot of Java, and the Java thread model is something the students readily can get a handle on, and we can do some standard simple exercises like you know, the contention models with the Chinese dinner model, with the chopstick model. All of that is readily doable in the Java model, and until now you have to either jump into something like POSIX threads, or I'm not even sure what the Microsoft people do. I know they have their own kind of package, and so the standardization is deeply important, but won't be in. You're quite right. It won't be directly in the class. Well, anyway, it's just wonderful to have your participation. I think you've made the class just enormously better for lots of students. When I've looked at your posts and your answers to questions, I mean, they're just amazing. Indeed, the pleasure of finding people like you, and in one case, my this thing you might find out when you do your MOOC for Coursera is they have a community TA, and that's somebody you get to select because they are so actively participating and so committed and talented that they're just willing to spend 24/7 helping everybody in posting. And in this case, it was Mike Roberts. So here I am at a poor state university. I know you're at a poor state university, and the amount of resources the state is about to turn over to us for a free course is not great. And then to see people in the community step up and be helpful in that way is remarkable. And indeed, as I say, it just immediately captured my attention, all of your wonderful posts. So I really thank you just for me, and thank you for the course. I don't know if you had any sort of final thoughts for today, or...
I've got two. First, I just wanted to say thanks for letting me experiment a little bit as a student in your course. It's a huge convenience for me. I was really happy to see you offering a C++ course. It was sort of serendipitous that I could do that as I was considering doing a course myself. The second thing that I'll say is for the students in your course, which is it's worth it to spend a significant amount of time learning programming as a craft as well as sort of a more academic topic. And the way to do that is to read and write and critique lots of code. Go out of your way to learn not just about the language and not just to write a few simple programs, but learn who are masters of the language, people that the community look up to, and find out how they program. One of the beautiful things about the world today is a lot of incredibly high-quality code is publicly available for you to read. So find out who you think are respected engineers who write in C++, and go seek out code that they write, and you'll be able to learn your craft from them. And that's a wonderful thing.
Okay, well, that's great advice. So thank you very much. And I'm sure you'll get comments after this post of our conversation. And good night.
Thanks, Ira. I appreciate it.
Okay, so I think we'll cut off here.
Okay.